Good afternoon, people. It depends on where you live. Anyway, today's topic is chemistry and the particles and the matters, the basics of chemistry. So before getting into the topic, let me talk about what this universe is made up of. This universe is made up of major components of two major components. One is matter, and another one is energy. When you say matter, we're talking about something that has anything that has mass and volume. When you say energy, we're referring to the things that don't have any mass or doesn't take up any volume. And these two are clearly a different thing, but according to Einstein, they're convertible. Anyway, so let's have a look at more formal definition of chemistry provided by Google and Oxford Dictionary. So this is a definition we want to have a look at, this one. According to the Oxford Dictionary, chemistry is a branch of science that deals with the identification of substances of which matter is composed, the investigation of their properties, and the ways how they interact, combine, and change. So we can say that the chemistry is basically a subject about the interaction between the matters and finding their properties and such. And another thing to have a look at, to remember, is that it's not only about the matter, it's also about the energy, as the interaction also involves the energy. Energy can be released, absorbed, and it can be in form of light, heat, whatever you want. So yeah, chemistry is not only about the matters, it's also about matter and it's also about energy. So when you have a closer look at what matter is, we can classify the matters into two broad categories. One, when matter is physically separable, we call them mixtures. When they're not, we call them pure substances. And mixture, again, can be separated into two smaller categories. If they have uniform composition, we call them homogeneous mixture. When they do not have uniform composition, we call them heterogeneous mixture. And in case of the substance, when pure substances, when they're chemically separable, we call them compounds. And when they are not chemically separable, we call them elements. In the example of element would be an atom, and a compound would be a molecule. In case of the heterogeneous, one big trait of heterogeneous mixture is that we can actually see the particles sometimes, because they're not uniform. They don't have uniform composition. Something like just like cocoa mix, like cocoa mix. We can see the particles if you have some good eyes. And in case of homogeneous, it is something that is very well dissolved, something like something like sugar solution. So like we can see that all these different types of matter, element, compound, heterogeneous, and homogeneous mixtures, they're all different, and they all have different examples. Anyway, so let's have a look at what element is. Element, for an example, atom, cannot really be separated via chemical means. And in case of when you say atom, I'm only talking about the chemical methods. When atom is to be separated, atom can be separated into three major components. One is proton. Another one is neutron, and the last one is electron. When they're talking about these three subatomic particles, we can say that they're particles that make up the element, but smaller than the atom. And even these particles, especially proton and neutron, can be separated into small particles called quarks. And well, these topics are more physics, so I'm not really planning to tackle this topic, but I might tackle some stuffs about electrons. Even though I didn't mention as a definition of chemistry, a lot of chemical reactions are all about electrons. So electron is an inevitable topic that I have to tackle in this series, I believe. So let's have a look at compound. Compound, for an example, a molecule can be chemically separated. Let's say this is a blue atom and this is an orange atom, and when you're to separate this into two, you have to chemically cut the covalent bond between these two atoms, and they are now elements which are not chemically separable. So if it's a compound, you can break it back down to element or another compound, something like molecule, and you get another molecule. You separate ionic compound and you get another ionic compound. That happens. And so when you talk about particles, what exactly are particles? And particles can be like biscuit crumbs, and it can be something like atoms. So we divide the scales to separate these two, all those particles in the world. We divide them into two scales. One is molecular scale, another one is microscopic scale. The biggest difference is that, to make it easier, microscopic scale is visible. If we have adequate equipment, just like microscope, we can have a look at those. We can clearly see those particles. For an example, like dust, bacteria, and virus. We can see them. We can actually see them using our technology and our equipment. Just like microscope, there are various types of microscope, but I can't really explain to you because I am not an expert in the microscopes. And when you talk about the molecular scale, as a title says, as a category name says, it's about molecule, about the size of the molecule. We can't really see them, even though we have the microscopes. We can't really see the actual shapes of the molecules and the atoms, but we can use some various implicit methods to guess how these atoms and particles look like some photoelectron spectroscopy, like PES. So we can use some various methods, and we're going to talk about that in the next video, I believe, history and atomic models. And anyway, to be more scientific and more mathematical, we can say the molecular scale is tackling 10 to the 9th scale of 10 to the 9th meters. In case of the microscopic scale, it varies, but usually when you say microscopic, it's 10 to the -6th meter scale. So it's quite a large gap when it's 1,000 times larger than the molecular scale. So yeah, particles can be visible, sometimes can be invisible. So I think that's it for today's video. Today we talked about what is this universe is made out of, matter and energy, and we talked about what matter is and what chemistry is, and we learned about the classification of the matter, and we talked about the two scales that are molecular scale and microscopic when you're handling the particles. So that's it. So please look forward for the next video, which is going to be about the atomic model and its history. So yeah, have a good night or a good day. See you later.